Hi everyone. I'm really excited to be here. I'm excited that you are all here at Dynatrace. And to keep it short, I will hand over to Tom, who will have the first words regarding Dynatrace.
That was quick.
Yes.
So does that work? I hope so. Yeah, also from my side, warm welcome in our lab here in Vienna. Great having you here. Quite a bunch of people. It's great seeing you. Question, can you hear me well back there? Okay. So very short, just about 50 minutes or so, or maybe 5. Let's try it with 5. Yeah, welcome to our... Okay. So to the meetup today, first of all, looking forward to the 2 talks about how we harness operators power by Christoph and how we utilize Backstage to improve the life of 1,000 plus developers. So looking forward to those 2 talks, and actually thanks a lot for taking the time and doing the talk today. Wolfgang and Christoph, looking forward to hear later. A little bit of background about Dynatrace, where we're coming from and what we're actually doing and what we're trying to solve. First of all, our main mission is that we make software running perfectly and also securely, and we're doing that by providing an observability solution which gives insight from the browser back to the infrastructure services and the whole chain and how everything is interconnected. We're doing that with a fully automated setup, also using artificial intelligence to keep everything connected and working smoothly. We're a company founded actually in Linz. It's an Austrian company founded back in 2005, so we're around a couple of months already. And our target market, when we talk a little bit about that, when we look at the Fortune 100, so the 100 biggest companies in the world, more than 75% of them are our customers. And our target market is the 15,000 biggest companies in the world. Give a little bit of insight. If you want to know more about Dynatrace, there are people around with Dynatrace swag, also other people. Just reach out and have a connection if you want to learn more and get more insights about how we work and what we do. And now there's the fun part. Housekeeping. So just to keep you aware, we are here when it's maybe getting warm. Please don't open the windows because otherwise the air conditioning will shut down and then the climate actually changes in here a little bit. If you want to go to the elevators, every one of you have received a white card. Maybe have already returned it. If you go to the elevators, there's a display on it. Just walk in front of it. It will light up and you can click directly to go down to the exit. If you want to go down for have a smoke, just let me know. I will happily join you. Yeah, don't open windows. We also had that. Toilets, just there, directly on the right-hand side, there's a door. You see the sign if you need it to get there. Also to let you know, we also will take pictures for social media. If you don't want to be on it, please raise your hand now so that I can see it already and can make sure that you're not on it. Perfect. Besides that, yeah, have fun with the talks and enjoy the snacks. There's the beer fridge. It's after work. There's also anti-alcoholic beverages in there. There's water, we have coffee, and a little bit later also food. And if you want to get to know a little bit more about how we work and also about the Dynatrace lab, would be now a good occasion to scan it. Otherwise, you also find it here. You get a little bit of background information, how we work. That's it from my end. Enjoy the talks, enjoy the evening, and more than happy to get to know some or maybe all of you.
Super, thanks a lot, Tom.
Thank you.
All right, before we go to the talks, before we come to the talks, before we get to the talks, okay, switch to English, please. We always have the session called Open News, where we throw news at each other. It was way too long. He's already shaking his head nervously, hoping it's not taking too long. So we cut it short to 5 minutes instead of 15. So 5 minutes. Do you have any news besides? By the way, if the new CEO of OpenAI is here, please raise your hand. No, okay. Besides that, any news regarding cloud? Yes. Wait a second. I have to throw this to you. No, I'll bring it to you, I guess. Fine.
It's not really cloud, but it's about front-end stuff. I've been using React for a while, and I've been trying all the different other frameworks, but I've recently tried this thing called Remix. I absolutely love it. You can basically have a website with no JavaScript. So I've not deployed it yet. I'm still running it all locally, but I think it's like supported in the cloud, like you can run it as like a function or something like that. So I'm making some YouTube tutorials about it as well, but it's nice.
Nice. What can you say it once again? Remix?
Remix, yeah. So it's like Remix is like it uses like web standards for like communication. So it uses like forms and like the actions to send stuff back to the server. So you don't have to have like Ajax and all this stuff with JavaScript. You can basically have a website that doesn't need JavaScript, which means that you have a really boring website, but it's like good for like, I guess, LinkedIn type websites or like Reddit type websites and stuff.
Great. Nice. Other news.
Okay.
And if you need more information about Remix, go to this gentleman on the table. Thanks a lot. Other news. I thought so. So I have something prepared. And it's not really news. Well, it's the opposite, to be honest. It's history. Today is the last session. Whoops. Today is the last session of this year. And I thought it's interesting to do a bit of a recap of what happened this year. So we started with AWS Well Architected. I don't know if you know it. If not, take a look at it. It's a really great framework for how to conduct your cloud endeavors. Then, DevOps without secrets. Yeah. So the question was, how can we first use perhaps something different than Terraform? Nordcloud was using Azure Biceps for that. Again, we were at Dynatrace. I'm really happy to be here. So thanks a lot again to Tom and all of you. And it was about Azure Managed Identities. So, well, we have the cloud agnostic tools, right, like Terraform and so on, and then we have the tools that the hyperscalers provide, and this is one of them. By the way, you find all of this at YouTube. We have our channel. I don't know if you know it. I can show you later on. Then we had zero-waste cloud computing, again at Dynatrace. Where else? About how can we reduce the footprint of what we're doing on a day-to-day life, starting from switching to OLED, increasing the black tones on your devices, up to traffic bandwidth, how can we reduce it, and so on. And then the session we had this year, so before that was Beyond the Rabbit Hole about RabbitMQ. And I'm really sorry that we had to cancel the last event. We really would have loved to have it, but people got sick and we were not able to have it, so we needed to cancel it. So that's what happened this year. And something unrelated to this meetup, but very related to CNCF. So this is the Vienna chapter of the CNCF. And we had our first Kubernetes Container Days this year. And Dynatrace played a big role there. So also, I don't know if you knew, but they were the ones who were taking all the risks. So thanks for taking the risks. And thanks for enabling this great event. And of course, thanks to all the others who were able to participate and manage it. I was none of those, so no thanks to me. Thanks to the others, please. Good. So any other news? Anything happening this year? The year is not long. 1 month left. Any event you need to go to? No?
Maybe just one. It's not for this year, but...
1 second. Whoops.
So it's not for this year, but next year. So you mentioned Kubernetes Container Days happening also next year. So
nice.
Note it on the calendar, most probably somewhere in October. So
perfect.
It was fun. We do it again.
Cool. So when is the Linux Foundation event taking place in Vienna?
I think a couple of weeks before. So we checked that, but I don't have the date in mind.
All right. But perhaps we should do a big event every 4 years. What's it called again? Oh my, the Cloud Native Days. No, not Cloud Native Days. Ah, come on. Oh man. Thanks to God internet. No, where is it? What's the big event? Cloud? Help me out. They were in Barcelona, they were in Amsterdam. KubeCon, yeah, thank you. Yeah, KubeCon, sorry, I was referring to KubeCon. All right, cool. So, a little experiment. There's a slot now called 10 minutes deep, and what I wanted to do is a little experiment for you, with you together. So what you see is a very empty sheet, draw.io, love it. And I would like to know, and perhaps some of you are not allowed to say it, but perhaps there are people that are allowed to say it. What are you working on at the moment? Does anyone want to say what he or she or they are working on at the moment? Yeah. Yes. One second, I have to throw it to you. Again. Remix.
Yeah, we're building a way to rent. We're building like a way to rent cafes. We were using Postgres originally, but then we decided we couldn't be bothered managing Postgres, so we're using SQLite now, and we're just going to manually replicate it with some streaming replication thing.
Okay, wait a second, but that's where I want to go to. Okay, right. So what you're saying, you're using SQLite?
Yeah.
Okay, great. Yeah, I know. Why?
Because it's less of a, because we're lazy, yeah. And we don't think we're going to grow very big very quickly. And
yeah, but what do you want to achieve by using SQLite?
the relational database.
Why do you need it?
Because we don't like NoSQL.
Okay, but using SQLite. Okay, I see.
Yeah.
What is the?
And it's nice to be able to just delete the database and then for testing and like create a test database and from scratch without having to mess around with like extra servers.
Okay, but why do you use SQLite? I mean, so okay, you have SQLite. I understand it. SQLite is a technology that enables you to do something. So what do you want to achieve?
Well, we don't need to have like scalability that much because we don't think we're going to be that big very soon. So it does everything we need with the schema that we have, and then we have like a layer on top of it for searching, it's like a Elasticsearch for Dummies type sense thing, which you can use with Docker.
What was it called?
Type sense.
No. The you said it's like Elasticsearch.
So we have like a relational database, but then users can search with various criteria, but we have like a batching process which copies some of the searchable data into a type sense, which is a sort of dummy version of like Elasticsearch.
Okay.
I tried Elasticsearch, but I could never understand how to use it properly. So.
How do you write this consearch?
Type sense.
No, this one, yeah.
Yeah, that's it. Yeah.
Okay.
You just did a Docker container, and then it's quite convenient.
Okay, nice. So this is the Elasticsearch alternative.
Yeah, it's like an easy. It's like simple Elasticsearch. Yeah.
Okay. 1 second. So what do you want to achieve by, how do I phrase this question?
It's fast searching. So we'll have fast searching built in. We can search with location and radiuses and like names, and we don't have to work out all the fancy string searching stuff.
Okay. So why do you need fast searching?
Well, we don't want to run this complicated query on the back end on a SQL relational database, and we'll have to figure out. We want to have like fuzzy matching, so we don't want to have like people that can't spell. We want them to be able to find things.
Okay.
I mean, I'm not very good at spelling, so like we don't want to have like complicated rejexes, and then it's just an amazing tool for. It's like one line of Docker, and you got this.
Easy to use. Yeah, that's cool. So what we're talking about here is we're talking about value drivers, right? So you have those things like you need fast searching, and you have technologies that enable this. You have the technology SQLite. Honestly, I don't know why you need it. So you have data, I guess?
Yeah, well, SQLite's used by the American, some American data archives. It's very stable, well known.
Yeah, but so SQLite enables you to do something, right?
Yeah, we have a relational database. So we're using Postgres before, but we just there's new technologies that allow you to basically back up SQLite like instantly. I've forgotten what it is. My co-founder, he's the expert in that kind of stuff. But there is like things that make SQLite better nowadays. And if you don't expect to grow big, you don't need to have like, a lot of this elastic cloud things. Then that's
No, totally get that.
Yeah.
Let me go here. And by the way, I'm very thankful that you're part of my experiment. Thanks a lot for that. I really appreciate it. So we have fast searching. You said you need fast searching. Because people, you need fast matching, you need to have it fast.
Yeah, it's like literally instantly as you type, you're getting like results back. We have a debounced search on the React side of things, and then.
So let's get to your product. Let's get to the product side. So you have fast searching, and your product needs it. So you have some kind of focus on fast searching. Is it a USP of your product, of what you're doing?
No, it's just like anything like Airbnb. They have you have that home page where you type search, and then you can search things like. So as soon as you'll go to the page, you'll immediately have search results. They won't even be logged in. Just like Airbnb, immediately give you we had like an original page explaining what we're doing, but we're like, just give them cafes immediately, and then they can click book, and then they can.
But that's where I wanted to go to.
Yeah.
So you said just get them coffee immediately?
No, they can. But we're having like ways to book spaces in cafes for meetings and things like that.
Okay, so people can book. What do you say? They can book. Sorry, I didn't understand. They can book.
They can reserve like a space in a cafe.
Oh, they can reserve a space in a cafe.
I mean, you could reserve. We have this schema open source, so you could basically make it to book anything you wanted. Like you could book like, I don't know, a bench on a park if you wanted or something. we made it. We had this thing. It's flexible. It's a schema that has like all this.
Okay, people can reserve a space.
Yeah.
And then you say that coffee shops are.
Yeah, we like coffee, but we could make this into. You can make this specialized into anything. There is actually people that do it. Like there is a website that allows you to book like a space in the coffee shop and all these different variations. But we just want to pick areas that we focus on, because then I like coffee, but some people might like other things to book spaces in. So I mean, I've also got this on YouTube, like explaining this process.
Okay, so to recap, people can reserve a space, perhaps in coffee shops, which seems to be an important topic because people love coffee shops, I guess.
Yeah, because coffee shops want extra money, right? So people, they don't like booking like places in like hotels for meetings because it can cost like, I don't know, 2,000 euros or 1,000 euros.
Yeah, I totally understand. And you want to provide them the ability to quickly find those spots, right?
Yeah.
Okay, cool. So they need to quickly find spots. Find a spot, perhaps they're in a hurry, they have a meeting, they forgot something, I don't know, they need to quickly find a spot, and then they're able to, they of course need fast searching, and for searching you enable with the technology TypeSense and SQLite, right?
Yeah.
Yes, perfect.
We don't need like TypeSense, but we don't have to think about that part, because it's there. It's just one night. Every night we will have like a batching process for copying over the data,
I understand. So another thing I see is that you want to have low operation overhead. That's what you said, right?
Yeah, pretty much. It's just so nice not having to like spin up an extra. I don't have to spin up Postgres on my Mac just to be able to run queries. The only thing I need to spin up is Docker for the TypeSense, and then I run the Remix server on the as well. So that I don't have to run Postgres as well.
All right, thanks.
I mean, I'm not saying anything bad about Postgres. I mean, it's way more powerful than SQLite, and maybe we'll have to go back to Postgres at some point. But
thanks a lot. What a great 15 minutes. Thanks a lot. Really happy that you volunteered. Thank you. So what did I want to? I thought the last months where we didn't have this, that it was getting too less interactive and too much only talks. And so I thought of an idea how to get something else in, and perhaps how to get a bit back to the bigger picture, because I think that's what we're missing a lot in day-to-day work. That we're saying, okay, like you did, and by the way, that was not staged. Thanks a lot. Like you did, we use SQLite. Okay, but why? And I have the feeling that a lot of times in our day-to-day work, we forget the why, and we forget why we're doing it, and we forget the USP of the product, and we forget about where the product is heading. So thanks a lot for that. What we did here is we identified the value drivers, so what things help us to get to our value. We identified the business objectives, and we identified the main objectives. So that's what we did here. It's called value driver tree. And again, thanks a lot for your participation. And without any delay, I would like to hand over to our first speaker. Christoph.
Okay. What is this talk about? Is about scaling observability using the power of Kubernetes operators. I will get into what that actually means in a bit. First of all, a few words about myself. My name is Christoph. I work at Dynatrace on the team that is maintaining or developing the operator that I want to talk about today. And yeah. So, a few words about the agenda. I want to get into why we need the operator, or what we are doing with the operator, what it was developed for, and then get into each of the components that is included now. So we have an operator, we have a webhook, and we have a CSR driver, and each of those were introduced at some point for a specific reason. Each of those things has a nice little icon except the webhook, and so we've kind of come up with a few different icons for the hook throughout the presentation. Let's see. But first, here's a quick marketing slide. The main relevant thing is just that with Dynatrace you can monitor a lot of different things, a lot of different technologies in the bottom. So it's like all these different things on different platforms, no matter basically what you are using and how you're using it. And there needs to be basically some way to collect this data. And for that, there is one thing. This is the agent. Well, it's not one agent. One agent is a marketing term. So you basically have multiple agents, each for each specific technology. And there needs to be some way for each of these specific agents to get into the process. So agent as a concept, what is it? We want to inject applications without the user requiring any manual efforts, any manual configuration. So what needs to happen for that? Well, something needs to attach the necessary metadata or the necessary information. In this case, this is an LD preload environment variable. Just for some background, LD preload is basically just a different binary that references a path that is then called before the actual application binary. This is how the agent is able to inject into the applications. And then if you don't want to have any manual configuration, there needs to be some process to actually put these binaries that are referenced in the LD preload into the container, into the process, so it can be used. And both of these things need to be set up and configured before the actual process startup. So yeah, those are the main important things. So now we have the one agent. We have it in some image. Don't really care what it looks like. So now we are on Kubernetes, and we want to kind of deploy the one agent on Kubernetes. So the easiest thing is to just put that image, put that container into a pod, deploy that pod on every node that we have using a daemon set. So daemon set just schedules a pod on each and every node, and then you have monitoring, or you have injection into each of the application pods, and the talk could be over here because it works. Since this is about operators, I want to get dive a bit deeper into maybe some of the problems that could be occurring if you just take this approach. First, this. So if I just have a daemon set, I need to manually maintain this daemon set. So I have this huge manifest. If something like a default changes, the image can be needs to be updated. The default arcs needs to be updated. Things like that just change frequently, and without a way to kind of manage that, I as a user have to do that. So I have to manage the manifest and have to manually update the manifest or the pods or the daemon sets whenever anything changes. There are more problems, but I want to gradually get into those. So what would be a better way to deploy something in Kubernetes? Well, I have my daemon set. I have my manifest of the daemon set. So I could just take Helm, wrap it in a nice Helm chart, and then go from there. I could abstract some parts of it. The main use cases for Helm are basically I have a simple deployment where I just need to configure a few different flags. But then I get into and it just basically installs it once. There is no lifecycle management, no gradual management of the resource after it's deployed. And the validation that I can have in Helm is very, very simple. There's no way to communicate with an API, no way to do anything more complicated other than check if a few resources are there, or if, I don't know, some spelling is correct, or some easy, simple string comparisons. On the other side, I have the operator concept, which is a bit more in-depth. So with an operator, I have the whole lifecycle management. So even after I install the resource, it basically still manages it, keeps it updated, and makes sure it's on the latest version. And then in addition to that, I have more opportunities to kind of add more fine-grained validation with the option for me to kind of validate on an API level or on a server level, and just easier written in an actual programming language than with Helm templates. Okay. So getting into the actual, or having the background out of the way, what is an operator in Kubernetes, really? The simplest description of an operator compared to a manifest would be, instead of managing my whole daemon set manifest, I instead have a custom resource that I fully control, that I can define in a way that I want to, that I don't care about the rest. So if we look at this example here, this example would lead to the same daemon set as the 100-line daemon set is generated the same way through this Dynacube than before. It's just managed differently. So instead of listening to just the daemon set, the operator listens to this custom resource, to this Dynacube. It reconciles, so it makes sure that the resources are in the expected state, and then by just listening to this Dynacube or to this custom resource, it just keeps them updated, keeps them on the latest version, and does that on a reconcile, basically on a loop and continuously. So instead of managing this manifest directly, as a user, I just have to manage this simple file. The operator then watches it and keeps the daemon set in check, and the daemon set then does the same thing. So I still get this agent pod scheduled on each and every node, and monitoring as I need it. Okay, so are there any problems with this approach? Is there anything we may need to fix? Yes, there are. So the main problem is that this approach, or the way the agent does the injection by itself is very container runtime specific. So meaning on the Kubernetes level, on the pod level, I don't have any clear indication that the injection happened or succeeded or anything. It all happens on a deeper level that is below Kubernetes. Then I have a race condition, meaning the agent pod is available on each and every node, but needs to be ready before any of the application pods are starting, before it can actually inject the pods. So in case of auto-scaling or similar scenarios, where you have basically the agent starting up at the same time, you always are missing out on monitoring for the first few pods, which is not something that is really the desired behavior. And in addition, usually the apps or pods on Kubernetes are split by namespace and not by node. And with agent running like with a single agent running on a specific node, you only can send the monitoring data to a single tenant for that node, and not really split the monitoring by namespaces as you would want to. Okay, so if this is not the best approach, what are some other options? I could move away from this whole approach and go to a bit of a different approach and kind of do less automation. So the first approach, or the simplest one, would be to just say, I want to do a build time injection, I want to modify my Docker file and manually download this agent. Like I have a build image, it builds some app, then I have the second stage that just copies over the binaries, and then I just have to put all these agent things into place, and then that's it. It just works. But that means I have to modify basically all the images that I own. I have to keep them updated to the latest version, and that's not like it works, but it's not really an easy behavior, and I have to basically have vendor-specific binaries or vendor-specific information in all my build pipelines. The other option would be to have runtime injection, which is basically to have this information, so the copying or the binaries and the environment variables on a Kubernetes manifest level. So to modify each of your deployments, each of your whatever pods resources you have, and add these manually for all of them. And then you don't have them in your build pipeline, but you still have somewhat, you still have vendor-specific information inside of all of your apps. So if this is not the desired approach, or if these are the options, then there is I can also say that there is a better approach to kind of use the runtime approach, but in an automated way without having to manually modify each of the manifests. So first, getting into the concept of what a webhook is again. In Kubernetes, we basically have, like, everything happens on an event, or most of the things happening lead to an event. So if a pod is created, if a pod is updated, if a pod is deleted, each of those events can be intercepted, and I, as a webhook, can get a callback and do things with those events. So for example, these are the different types. So I can validate a create event, I can mutate a create event, so I can modify what happened to the pod that is created, and I can convert basically one API version to the other if I want to work with only a specific one. So how is that actually used in our case? So we mentioned some more fine-grained validation, and this is basically the way to do it. So whenever there is a custom resource applied, so this whole configuration file, the API server does not directly schedule or apply it, but instead we as the webhook get a chance to kind of have a say. and either admit it with a warning or without a warning, or just error out and say this is not allowed. And this kind of gives us the option to provide some early feedback. So instead of failing later by not being able to schedule specific resources or having other missing information, I can give a clear error message early enough in the process, and yeah, customer can then or user can then kind of react to it. And with a more specific example, in our case, this like API URL field is not optional, so it's a required field. So if it is empty, then we can't really do anything. There's nothing we can work with. So instead of just allowing it, we kind of error, or we return a forbidden response and say, yeah, this Dynatrace is missing the API URL. And then instead of allowing it and doing nothing or not working with it, we can, they can edit it and apply it again with a working spec. The other important webhook category is the mutation webhook. This basically allows you to intercept any of the create, update, or whatever events for example, for pods. So before a pod is scheduled, the API server kind of goes to the webhook again, different type of webhook, but could be the same pod in the callback, and then you can either create the pod as is, modify the pod, and add some additional information to it, or even error in the case that there is something not missing. The important thing here is the pod is not scheduled yet. So for example, node-specific information is missing, so that needs to be handled differently. So how does the operator now use this mutation webhook to kind of mirror the injection or the agent injection? So starting off with a sample pod, we kind of have a simple app container with nothing much, just an image and image in a single container. If the mutation webhook now gets the chance to, or if it is now in a namespace that is monitored, then the mutation webhook kind of gets to modify this pod, and we get the following information added. So this is this LD preload variable that we kind of have heard of before. Then there is a volume, and volume mounts to both the container and the init container to kind of provide a shared directory. And then in the init container, this download or this making sure that the agent is there before the container starts up is handled, and then stored in the shared volume and provided to the application container. Yes. So this was now the example of what it does. So how can it actually be configured? The mutating webhook configuration is actually a cluster-wide resource. So you basically can select or can configure monitoring on the whole cluster on a per namespace basis. So one of the requirements was basically it should be able to monitor all namespaces by default. So, but we also have this namespace selector that only listens to this specific label. So meaning you can only, or the webhook only listens to namespaces with this label. So how do these kind of two requirements fit together? And that was kind of resolved by combining these two components. So I now have one webhook configuration that only listens to namespaces with a specific label, and I have a different component that is making sure that the label exists on namespaces that kind of listen or that are supposed to have this monitoring according to the configuration. So it's just both components working together in tandem to get monitoring for the namespaces that they are supposed to have. Then this all works fine if it's just a single webhook. No issues. It's only the single webhook kind of modifying the pod, nothing else kind of interfering there. But that's not really reality. So there is always kind of other players, other webhooks that also want to modify the application pods. Some examples for that are Istio or Vault Operator. Just some fun times with those. And the problem there is that those webhooks are called in alphabetical order. So there is no way for us or any other webhook to kind of control that. It's not really no one prefixes all their operator names with like a lot of A's, so it's the first one. But instead, it is handled differently by a reinvocation policy. So each webhook needs to be aware of the fact that they may or may not be the first or the last webhook in the chain. So they can be invoked or called multiple times in a row, or not in a row, but after each other. So in that sense, if a pod is modified by a webhook and then is modified by a different webhook, that first webhook is called again if it's configured that way. So, and to kind of visualize how that can happen with the Istio webhook, it's basically if a pod is mutated by the Dynatrace webhook in this case, it's fine. Everything is added, init container is added, a volume is added. Then the Istio webhook is called. It mutates the same pod, adds another init container, adds a sidecar, whatever Istio does to the application pod. And then since the Dynatrace webhook has this reinvocation policy configured, it is called again and is able to kind of, in addition to the initial modification, also modify this new init container sidecars that were added by the Istio webhook. And then it actually stops, since the Istio webhook does not have any reinvocation configured. If it had any reinvocation configured, this would go on for a little longer, but there is some precautions in place to not kind of lead into an endless loop, an infinite loop. Okay, so there is now a webhook in place. It kind of intercepts or kind of works with the whole cluster. It's probably time to kind of make sure we don't break any or we make sure to break as little environments as possible. So what can we do in that area, or what can be done in that area? First of all, the webhook itself can be, replicas can be increased, and using topology spread constraints, you can make sure those replicas are actually scheduled on different nodes, different regions. So if one node dies and the webhook is scheduled there, it does not kind of break the whole monitoring. And then in addition to that, there's also the failure policy plus timeout, where if the webhook is not ready to kind of handle the mutation request in the timeout, in the amount of time the timeout allows, the failure policy can be set to ignore, to kind of still allow the application pod to start, but without any modifications by the webhook. And then for our init container that is added, it's like if it errors, it shouldn't actually error, to kind of not block the startup. So this whole idea is to not block any application pods. Or to not block any pods. It's more important that those can start up and no monitoring is there than to block them forever to have monitoring. Okay, so there are still some problems, or there is still some optimization potential in the webhook approach. Mainly the fact that for each application pod, each and every init container needs to download these binaries and put them into the pod storage, and make sure that happens before the actual application startup. So you have increased storage, increased network traffic, and increased startup time for your actual pod, and you have that for every single kind of app that you have. So there is a way to kind of try and optimize that as well. So there is a Kubernetes concept of a CSI driver for that tries to optimize the download and improve that, kind of reduce that to once per node instead of once per pod. So before getting into how that is used, quick intro of what a CSI driver actually is. So CSI stands for the Container Storage Interface. It's basically a way for Kubernetes, or a way Kubernetes allows us to provide some custom mount logic. So it's just a volume, but a volume that has a custom mount provider. And this is basically one cluster-wide object to kind of register your CSI driver. In itself, it doesn't do anything, but it just tells it, if you have a CSI volume that requests a CSI driver of like this name, then there will be something there that handles those requests. And that something has to be a pod that is scheduled on each and every node. So what needs to happen is that I have a daemon set that is basically this CSI driver with custom logic in it. But before any of this custom logic can be called, I need to use some of the CSI sidecars that are provided by the community to kind of make sure it is a kubelet or the node is actually aware of our CSI driver. For that, we have two components. There exist two components. The first is the registrar, that basically, if there is a CSI object of that name, it registers itself by that name to the node, and starting by that moment, if there is a CSI volume requested with that name, it's going to be able to handle it. And there is also a small liveness probe that basically just provides an endpoint to make sure that it's still healthy. Those are just two containers that we can use to kind of provide the base functionality, and that gives us the ability to kind of provide our custom logic, or add some custom logic. The main one being this first provisioner container. So instead of each pod downloading the binaries by themselves, we now have a single pod that is watching the custom users, so this configuration of what versions are required by themselves, and then it downloads these versions and make sure they're available on the node file system in a way that they are accessible by each of the pods. And just to kind of visualize that, so instead of kind of each application pod hitting the server at once or sequentially, whatever direction, I just have one single CSI driver pod per node, and that downloads those pods, those agent versions, and I can then just reuse them for each of these application containers, application pods, without requiring a new download. So that reduces the network traffic and the storage by however many pods are scheduled on the node. So I now have these binaries available on the node. How can I actually use them? As I mentioned, there is this CSI volume, so it's basically just the rest of the container is mostly, or the rest of the pod is mostly the same. I just have a CSI volume instead of an empty here, and it just references my CSI driver by name. So if kubelet kind of sees a volume by that name, it will kind of forward that request to the CSI driver. It will be able to handle the mount request, publish the volume, and if nothing goes wrong, the pod can be scheduled then without any issues. And with those same binaries from the node, without requiring a new download. There is some more optimization that I don't want to go too deep into, but basically, if you were to just copy the binaries over from the node, you would not need the network traffic, but you would still have like storage per port. Instead, those binaries can be just linked by OLFS, so you only have the diff, so the config files that change, count as additional storage per port. So it's instead of requiring storage for each port, you just require the storage once per version, and it's just the config, which is a few kilobytes per port. And then we also have the storage optimization there. Okay, so we kind of introduced another component that could break customer apps or could break apps that are injected by the webhook, because at this point the webhook already has attached a CSI volume. There needs to be something handling those CSI volumes. If there is not, they will just fail indefinitely. So we've kind of tried to reduce the risk of that happening as much as possible. I mean, the easiest thing is to just split the containers. So you have the thing or the container downloading the versions kind of failing independently. It's the most memory intensive part that can run out of memory quickly, but if that happens, the server, so the actual container handling the mount requests should still be available. It won't be able to fulfill the mount, but it will be able to kind of count how many attempts were already done. And then we can kind of implement a custom timeout in the sense that you count how many of those requests or mount attempts were made already. And after some number of attempts, you can just mount an empty volume instead of continuing to try and get monitoring and block the pod indefinitely. So you will not have the expected monitoring, but you will at least not block the application pod forever. Okay, so this is the current kind of approach. It still has some problems, but I mean, we're kind of willing to live with those. The main problem is that it requires a privileged container because this mount and propagation of this bidirectional mount propagation of mounting a container in another container, it requires those permissions. It's a restrictions that all CSI drivers have to kind of live with. Then the main or a big issue on OpenShift, I don't know if anyone is using OpenShift here, that we've had until recently is that by default, the CSI volumes are not actually allowed for any application pods. So you would have to basically, as a user, have to modify your custom SCC or create your own new one. And that is just some friction that has led to some friction in the past. So it's good to see that starting with the latest OpenShift version, at least this kind of restriction is removed, and it will be easier to kind of schedule pods like this in the future. And since, I mean, it should not be a problem, but it's still kind of hidden from a user, since all of these versions or these binaries are not stored in a way where they're cleaned up automatically by Kubernetes, but stored in the node file system. There also needs to be additional custom logic to kind of clean up all old agent versions, so garbage collect versions that are no longer in use. And that's just some additional work that you have to be aware of. Okay, so finally, where does that kind of end up, or where does that lead to with the operator? In essence, we have one custom resource that is kind of controlled by the user. It is constantly watched by an operator pod that make sure that the environment, the namespaces, the secrets are all set up and configured in a way that the rest of the components can work correctly. Then there is multiple webhook replicas kind of spread over multiple nodes that handle these validation and mutating requests. And then you also have a CSI driver that is scheduled using a daemon set and kind of handles the download and makes sure that the necessary binaries are available as needed, and new applications can be injected, monitored with as little impact as possible. Okay, and with that, thanks for your attention, and if there are any questions, then feel free.
Questions? You get the cube.
Thank you. Is it working? Okay. Yeah, thank you for the talk. It was very interesting. My name is Ilya Kaznachev. I'm a cloud native architect, and I also went through some similar stuff when I was working at a Kubernetes as a service platform. And I'm curious, I'm not getting the whole idea of the CSI driver optimization. Does it prepares the volume with some kind of binary on it when the pod requests the volume? Yes or not?
So the question is, does the CSI driver prepare?
What is the optimization exactly with the CSI driver?
I mean, it's basically twofold. First of all, you don't have to download the binaries per pod.
Yeah.
So that is handled in a CSI driver. And when you then mount, or when the CSI driver then handles the mount, you don't need to kind of configure anything or need to configure less in the actual application pod. This is all handled in a CSI driver.
So am I right that instead of mounting kind of like empty volume, you're mounting the volume with the binary?
Yeah, exactly.
Okay. That's interesting. Is it always working?
I mean, no, but but it kind of depends. If there are, for example, network issues, and then that's why we implemented some parts, like some resilience features, to kind of limit the impact of kind of these issues.
Yeah, I'm asking because I have very painful experience with CSI drivers, and like it works like 90%, something like that. So yeah, interesting to hear that it's used for optimization like that. Very well, thank you.
Any more questions? Anywhere? Yeah.
Hi, thank you. It was very interesting. I wonder if you do updates of the version of your plugin, you need to restart the pods. So also all the application pods need to be restarted at least once when you have triggered an update of the version of your agent.
Yeah. If they want the latest version, but usually it's fine if they keep running with whatever version they have until they are restarted for a different reason. So it's not something that is done by the operator, it's something that is done by the user. And whenever that pod is then recreated for whatever reason, they will get the latest version at the time.
And one follow-up question, if I may. Is this also already using eBPF stuff?
No.
No, but this would be the next step, I would expect.
Not
Because then you maybe would need not a lot of this magic anymore, maybe?
I mean, I don't really see the connection to eBPF here in this part. I mean, the operator just sets up the agent. The agent itself is then doing the monitoring.
Yeah. I just wonder because I just did some testing with some of these eBPF, let's call it monitoring agents, and you simply run it on a node and you can immediately catch everything you want from every bot, if you like.
Yeah, it's possible.
So this is nothing that is done here at this point. Okay,
No.
thanks.
There are some efforts in different areas, but that's the operator part is basically just setting up the agent in a way that it can monitor, and that monitoring can also happen using eBPF.
Understood.
Anyone else? Yeah.
I also think that the part of the CSI driver is a very good idea. To be honest, I had never thought in this direction, but wouldn't it also be possible to use the different agent versions as you already injecting a container into the application pod, to use different container images and already use the overlay FS of the underneath container environment for the caching? Because if I understand right, the CSI driver optimization is always on the node base. And when I'm going to use the container images directly with the agent in it, then I can already use the caching mechanisms which kubelet and the underneath container environment will provide.
Yeah, so the thing is, the agent is not run as a sidecar, but instead the binaries are stored in a location where the actual application container can access them. So if it would be, no, that's currently not possible.
Yeah, okay, I understand, because at the moment it's just an initial container, not
running.
Exactly.
So
okay.
It
Good.
needs to be basically in the same process as the application.
Okay, good. Then it does make sense for me.
Hope there are no agent developers here that can correct me.
Thank you.
Anyone else?
I do have two questions, if it's fine. So the first one, which degree of automation did you are you already achieving with your operator implementation? So there are 4 degrees.
You mean those Red Hat things? The Red Hat
sure.
levels? I think it's like the second to last because we don't have auto-scaling.
Okay. And the second question is, what are your future plans for this operator? Would you consider it feature complete and you are focusing on resilience features, or is there any more coming up?
I mean, so our current main efforts are basically to make it more user-friendly, more modular. So I haven't really shown it, but there is this one big custom resource that we use to kind of configure the whole thing. It's nice, it's served its purpose, but it's kind of hard to develop with one kind of reconcile loop listening to the custom resource. So our current efforts are to just currently to kind of split this up into multiple custom resources, make it more modular, allow multiple teams to kind of work on it or more easily work on it and kind of go in that area, and to kind of go in a direction where the operator manages more and multiple components other than the monitoring it currently does.
Last chance for questions? No? Everyone happy? Then, thanks so much.
Thank you.
Please make the switch of the PC to the next presenter. Yes, please. Go ahead.
Okay, all good. Got to stay hydrated. Yeah, thanks for joining. I'm Wolfgang. I work at Dynatrace as a product manager more focused on internal topics. So my area of responsibility is more on our internal engineering processes, the internal developer portal, and also how we release software, how we deliver stuff at Dynatrace. And I'd like to talk about how we use Backstage at Dynatrace and which experiences we have made, where we are right now. Big disappointment right at the beginning. We are not yet there where I thought we will be when I wrote the abstract. So we're not yet at the stage where it's really helping us with 1,000+ developers. So sorry about that. But I'll get to that. Hopefully we're there in a year, but not yet. But before we kick it off, just one quick question. Who of you has any experience with Backstage or other developer portals? Okay, a few, not so many. The rest of you, anything around software catalogs, ITIL stuff or things like that, or is that just not a topic? Okay, shaking heads, awesome. Yeah, then let's get started. And as I said, it took longer for us, or it's taking longer than I expected. And I was thinking about an analogy, how we can make that, and that usual, it's a marathon, it's a sprint with that long road during the desert is a bit boring. So I thought I'd go with my COVID project that I did together with my wife, which was tiling our basement. That also took way longer than expected, and it was a lot of hard work. So that is quite a similarity we have there. So yeah, let's get going. How it started. Dynatrace a few years ago was, as my colleague pointed out earlier, we had those different features, and most of that was, or we still have them, most of that was stored in a couple of quite large repositories where people were changing code, adding code, testing stuff. Some would call it a monolith, some not, but mostly it was a big repository where everything was built and shipped together. So if you did something new, you didn't have to worry that much about where you add it, how to version it, how to deliver it. That had some advantages. It was quite easy for developers to add new stuff, or you just add a new Gradle project in there and you're pretty much done. But there are downsides, and with growing size, it becomes slower and slower. It becomes more effort to maintain it. You have to invest into making sure that builds still work. It's not getting too slow. Some things only happen overnight, which is also the wrong direction, going back to the good old days of nightly integration tests and so on. So we didn't want that. At that time, we also had releases every 14 days. So we had automation for that to reduce the manual effort, but overall, it was a bit, feeling a bit old-fashioned. And then the idea for the Dynatrace platform came up with a lot of new features, more flexibility about using the platform, building stuff on top of it. So the question was, of course, how do we get there? In those old days with the more large-scale repositories, we had a central team or a bunch of central teams that were responsible for maintaining those repos, creating new builds. If you needed to start something new, you had to talk to them, or back at the time I was a team lead there, had to talk to me. And then something happened in the next sprint, or maybe the sprint after that. Obviously, that doesn't fly if you want to build a platform where things have to be fast and you want to be able to be more agile. So we came up with the idea to build something we called the project initializer. Since we are quite creative, we wanted to build something that initializes projects. So create a new Git repo, create a Jenkins build, provide some basic templating in there to get people started with some basic, Gradle stuff, a Jenkins pipeline, and so on. We started with that about mid-2020. Back then, there was a project from Spotify release called Backstage. We thought, yeah, that's pretty new. This doesn't do all the things we want. We only need templating. We build it ourselves. It's easier than adopting something else. Let's just go with that. Yeah. You might think it didn't work. Actually, it worked quite well, and it is still used by a couple of different teams. However, we were getting to a situation more like herding cats. So a lot of projects being created, not really staying in sync with the template. Sorry. Also, we saw some limits to focusing just on what we did initially. So we realized, okay, templating is not enough, because why? There are a lot of other questions we would like to have answered, because we saw that people are creating new projects, but afterwards we just lose track of what's going on. So getting back to my tiles, where to start with tiling, you start at the door, and we also figured that we start with something we are interested in ourselves. Who is actually responsible for a component or a service? So if somebody created a project or created a service, who to reach out to if something breaks, who should get automated notifications for build failures, test failures, who to reach out if a new library version is coming out and should be used. Which resources do you need? Do you need a database? Do you need a Kubernetes cluster? Do you need, I don't know, Web logic? Hopefully not, but who knows? So how to keep track of that? which APIs do you use? Which dependencies to other services are in there? My favorite question, where is the documentation? How to find it, where to get there, how to get there. Where is it deployed? Is it running anywhere? Do we use it in dev? Do we use it in our test instances? So Dynatrace, we call them hardening. Is it released in production already? Which versions are running where? How are my builds doing? Are my builds green? Or do I have any problems there? And where can I find the self-monitoring data? Of course, interesting to know, is it actually used? Somebody looking at what I built, or do I have no usage at all? And of course, it would have been quite interesting to build all of that ourselves. But since the talk is about Backstage and not the initializer, you can figure which decision we took. And it was not to invest further in our own solution, but rather start with adopting an off-the-shelf product, which is called Backstage. So that's, for those, since not so many hands were raised, just as a brief intro, it's a project originally provided by Spotify that was open sourced in about March 2020, which is a framework for building internal developer portals. And the internal developer portal is typically what you use to answer those questions, and even more than what I just showed. And we are now using it in parts of Dynatrace. We started in my own teams, so things related to that internal delivery, that internal processes. And of course, we also use it for Backstage itself. So we can answer the questions that I showed earlier, things like which team is responsible. We have a team that's called delivery tooling and enablement. It's quite easy to see who the owner of that is. We have a link to our self-monitoring. We have a link to the documentation. And we also use other plugins that allow you to see where are the Docker images. Do we have any security vulnerabilities there? How is CI/CD doing? So there's a Jenkins integration, for example, and also an Argo integration that shows how the deployments are doing, which versions are deployed where. Dependencies and so on are listed, and also, of course, the documentation and code quality with the Sonar integration. That case, the relations are also quite straightforward. It can be a bit more difficult. We also onboarded parts of that larger scale, older Dynatrace part, in that case, the ActiveGate. So that is the routing and monitoring component of Dynatrace, where all the traffic from the agent goes through when it's sent to the server. That also has a couple of components. The colleagues there started to use Backstage because they also saw the value in answering those questions about ownership, about just quite obvious things like having links to the different pages where you can find help, get help, and documentation, for example. What was also key for us was integrating existing tools, and we have one thing that was quite important. It's called Dynatrace Teams. We use it to specify our teams, so who is in which team, how is the team called, how is the org structure looking around the team. Backstage has a similar concept, and of course, we didn't want to duplicate that data, so we started off with integrating it. And that is also quite cool, because now you can, once again, the delivery tooling and enablement colleagues have to serve as an example, but you can look at the team page in Backstage and also see right away which services or which deployments are owned by this team, so what is this team responsible for. Okay, that's quite nice. We also integrated our Stack Overflow instance. We use Stack Overflow for Teams, I think it's called, at Dynatrace. So the cool thing here is that you have one search in Backstage that includes all the documentation that you have in Backstage, so all the tech docs that you put in there, so in Markdown format. But you can add via plugins also other properties that you can search, like Stack Overflow, for example, or also architectural decision records. So that is quite helpful with having one point to search and not having to figure out, is it in Wiki, is it in SharePoint, is it in Stack Overflow? No, sorry. So that's where we are right now. So we use it in parts, but how to grow, how to continue, how to get forward. And what was a bit of a surprise for me, since I thought it's cool, we can answer a lot of questions, we can provide something that's helpful. And And that was not an actual conversation happening, but it's a good summary of a few other conversations that happened. Yeah, why do I have to use it? Why should I use it? What's in it for me from the dev's perspective? Was a bit of a bummer, I have to admit, because I was expecting everybody to be full on board with, yeah, cool, Backstage, let's do that. But we got together with a few colleagues and thought about a bit more process approach to actually roll it out in a larger scale. So we considered which stakeholders do we actually want to look at. So you can tell I'm the product manager. It's less technical than the previous talk. Sorry about that. Which stakeholders are we talking about? What is the user journey? What do we actually expect people to do in there? And then start small and grow from there. And we looked at our platform image and thought which is the area where we want to grow most, which is probably the part where we can have the most impact. And for us, it was the top where we have what's called the Dynatrace apps, which is something you can start coding yourself. So you can extend Dynatrace based on the APIs and on the queries that we provide and create your own app. And we thought that's the spot where we have to, or where we can help with self-service solutions and more automation. That's what we're doing right now. So for the Dynatrace apps, there's a developer portal where you can see how to do that. And we want to help with automating that by creating that workspace template. So the app comes with the CLI, and you need a bit of boilerplate around it to use it. Of course, we don't want people only to use it on the local machine and then have something that they want to ship. But coming from that internal engineering and testing part, I'm always quite keen on having a CI in place and the proper release process. So we need a workspace, we need a Git repo, we need a build for that. And that is exactly what we are automating using Backstage by providing the template for a workspace that gives you everything that you need to get started. We have now also integrated a tool called Gitpod, that's over here. I didn't put it here, sorry, I was skipping something. We also do the repo creation via GitOps, that's what I should mention here. So we wanted to have a bit more auditing in place to also see when is a repo created, which settings are applied there. We don't want people always only clicking around in a Bitbucket UI or maybe a GitHub UI, but do it via GitOps to have it in an automated fashion and also have a record of what happened where. And then at the end, we are now at the stage where on the one hand you get that workspace spun up in Gitpod, so that is a remote IDE solution that we're using that starts your workspace in a container in a Kubernetes cluster, which is quite nice since you get Visual Studio Code, for example, or also IntelliJ, that you can connect there, or you can use it in the browser and get coding right away. So from creating the template to being able to do something that's like a minute or so, that's quite cool. We're also working on automatic deployment for those new apps to get it set up in our dev environment to also have that available as fast as possible. And of course also automating the self-monitoring setup to make sure that if you have a new app, as said, is anybody using it? Do they have any performance problems? What's going on in there? No, super spreader event. That's where we are currently. There are a few hurdles ahead, and I'd like to point out 3 of them. So on the one hand, since we had our initializer approach, so that quite template things, scaffolding focused origin of the whole project, we now have a lot of existing projects lying around. And we need to find a way how to onboard them. And right now, that is quite a manual process. And of course, I don't want to do some things manually, and others also don't want to, so we need to find a way to automate that. Apps have dependencies on an SDK, and SDK encapsulates an API. And we started now with onboarding those dependencies, so those SDKs that are used as dependencies in Backstage to have that foundation in place for further apps. That was already the first part here. We are still working on the actual app onboarding, since we also try to minimize the manual effort required here. But that's in the making right now. What was quite helpful here was a plugin for validating the entities. So the whole Backstage container catalog, is based on YAML files that you put in your code repo, and you specify the information that you'd like to see in your catalog, like the owner, like all those links I talked about earlier, also the dependencies on other systems. And I mean, I was studying in a time when XML and XSLT was quite popular, and I'm of the unpopular opinion that I miss it quite a lot since I'm always struggling with YAML syntax. Anyway, for Backstage, there's the entity validator where you can, before committing it and wondering why nothing shows up, you can verify, do I have the correct syntax? Do I reference any entities that aren't present, or do I have any other problems? There are a few checks that we're doing right now. So that already helps with at least visualizing what's happening and making sure that people that are maybe not hardcore power users now also have a bit of success with onboarding their stuff. So automation was the first hurdle. The next one is templating workflows. So right now, we are a bit limited in what we'd like to do, especially when it comes to the GitOps part, since Backstage can't wait for things to happen. So what do I mean by that? You go through the template and you create the repo, something is pushed there. In our case, we would need to wait for a PR to be merged, for example, to actually use that GitOps approach fully and wait for that. Or sometimes if you want to do something like waiting for another user to provide some input, maybe in the form of an approver, you want to create a new resource, a new database by pushing something to a state repo, but it needs to be approved by somebody for, I don't know, resource constraints or license usage costs or something like that. That's also not possible right now. There is an open request for that, and that is something we are also planning to contribute, since we see that as a big blocker, especially around, as I said, that GitOpsy way of how we like to create resources and repositories. And the third hurdle for us, since the onboarding is taking some time, it can be a challenge to ensure that things keep working. So if you put something in, use the validator, you add some stuff, you're happy that it works, you merge it, go home, next day it doesn't work anymore because somebody else changed something. That can be a bit frustrating, and that's why it's important to also ensure that things are working, and not only when it's fully rolled out and everybody's using it, but already start with that earlier. And of course, as you have heard, Dynatrace, observability company, there's a website from a colleague who has that as his topic with isobservable.io. So what is it about for us in the case of Backstage? It's about availability, so can people use it, especially when you start putting documentation there, for example. It is crucial to have that available. If there is some incident going on and you need to look up the doc and the doc isn't there because the developer portal isn't working, yeah, sad. Are users using it? So do we have colleagues using it? Is there anything that is slowing us down? Can we optimize performance? And what about the depending systems? Are they working? Are they performing? So the first thing that we also built in, of course, in Dynatrace, but you can also do that with other solutions, and especially for this case, there is a plugin for Backstage as well that allows you to keep track of misconfigurations based on the Backstage logs to see things I mentioned earlier. Somebody changes something in the entity format and stuff doesn't work anymore. You see that in the logs when entities are not found, for example, or the syntax is invalid. We use it based on our log monitoring and look for important stuff in there to see, okay, maybe something is broken, maybe something was added that shouldn't have been added, and then reach out to the people that might be responsible. Next thing is, once again, logs. Also, keeping track of what's going on in the logs and looking for more critical errors that you might see there, like entity not found or some external URL that is referenced and not allowed. So that's part of the monitoring. We also use synthetic monitoring, so having some automation to make sure that it's up and running, to verify that the availability goals are met from different locations, since we have colleagues in Gdansk, in Barcelona, in Linz, in Vienna. Sorry. So that's working. Also then to see where is usage coming from, which are the top pages, so what is actually used, and maybe also keep track of where do we have to maybe point attention to features that aren't as popular as they should be. No, what's going on now? Sorry. The PM who's not used to talking, that's unusual. Yeah, the optimization part, as said earlier, looking at the actual page performance, are things loading slow? Is something not working there? Do we have any errors on the client side? In that case, also figuring out why something loads for 22 seconds, which is probably 21 seconds longer than what I would expect. So being able to keep track of that, and then also to verify why stuff behaves the way it behaves. So basic web performance stuff that we're doing here. And as said earlier, the important thing to also monitor the dependencies. So Backstage is a application that has database in the backend. We use Postgres. It's running on Kubernetes, so we'd also like to make sure that the stuff that we use in the backend works, and if we have any problems, see where they actually come from. So distributed tracing is helping us here to figure out the dependencies and see what we're using there. No. Okay, so now tiles are in. What's next? Are we done? Of course not. What are our next steps? So for us, as said, automation supported onboarding for Dynatrace apps that are built based on NPM. So that is what I see as the most important thing to enable the further usage and make it easy to use. Aside from that, of course, extending the templating. So we want to use it more. We want to get rid of manual interactions, not because we don't like our colleagues, but because it's faster to do it via a workflow. So extending templating, making sure we cover more use cases there. And third, as I pointed out, establishing Backstage as the cornerstone for developing Dynatrace apps at Dynatrace. So what should the key takeaways be from today? The lesson learned for me, treat the developer platform as a product. So what does that mean? Think about the user journey. Think about the stakeholders. Also gets to the fourth part, make sure it's available, make sure it follows the same observability standards that you also follow for production apps, since it is production internally and developers are your customers, so in that case it has to work. Second lesson learned, and I think that is even more important than the first one, build it and they will come somehow never works. So just having a great solution and then expecting everybody is going all in because you provided something, doesn't work. So needs some hand-holding, it needs effort, and it's an ongoing effort. So that points to the third one. It takes time. It doesn't come overnight. It is helpful, but still establishing a tool like Backstage or also other developer portals is a big investment. In our case, we have almost 2 FTEs, so two people working on that to extend it, to keep it up and running, to also work on the integrations that I said, or also the changes that we want to contribute back to the open source version. So it is an investment that has to be considered, and as I said, doesn't happen overnight, and takes time and a plan, which goes with treating it as a product. Yeah, and I already covered the observability, so making sure that stuff works, because you want people to use it and not be frustrated because it doesn't work. And that's it. So basement is done. My bike is back in. The lemon tree died in the meantime, so that's an old photo. But yeah, we're good. basement is done. Backstage is almost done. So that's it for me right now. Thank you for your attention. And if you have any questions, please.
Do you have any?
Thank you for the presentation. How did you approach problem 2 from the key takeaways? And basically, what was your solution, let's just say?
Your problem, I would say that the solution, I guess there are multiple solutions. Our approach was to, as said, look at where we think it makes most sense. So which is the part that is growing the fastest, which is the area where that whole story with being able to create new things without having to wait for somebody to do something manually, being able to also leverage the different integrations when it comes to seeing which systems you interact with. That was part of the solution here, and for us it was reaching out to the stakeholders. So in that case, a colleague on the product management side to get together and say, what do you think? What can we improve in terms of the developer experience? Always a bit of a fuzzy buzzword, but what does it mean for us, and what does improving the developer experience mean when it comes to automating stuff, providing a portal that makes it easier for devs to actually use it.
Thank you.
Any other questions? Yeah.
Yes, thanks for the talk. I would have a question. I'm curious to know how you have measured the increasement of productivity by using Backstage compared to what you've used before.
To be honest, I don't think we've measured that so far. We had some ideas, but the KPIs are not fully in place yet. So the one thing I'd be very curious to measure is the time it takes to the first or to the 10th pull request. So that's a pretty common one to look at. Does it actually help with starting up new projects? How long does it take for a developer to make the first PR? That is something we want to do. But for metrics like we saved hundreds of dollars or hundreds of thousands of dollars because we introduced it, that's something we don't have at the moment, unfortunately. But I think measuring developer productivity is a bit of a slippery slope. So
yeah, but the talk just said that you have increased the productivity, so I just asked if you have measured it, because
it's part of the part where we're not yet there yet. No, what we've seen is what we definitely saw is what I mentioned with the apps to start up, so getting from the template to having a workspace ready. Previously, I mean, for me, I have to download Node, or I have to update Node because I realize I haven't used it, and I have to update NPM, then I have to update the CLI because that's also not used in a while. Now I can just click on the template, create something, and have the workspace ready. So that is something we are not currently measuring in a structured way. It needs to be done. And I would hope that we can then also answer the question how many percent of time we used. What has been beneficial, but that is still also more anecdotal evidence and not in hard numbers, is having simply those links ready and having transparency who is responsible for a certain component. Where is the documentation? It's really things that you can find. I mean, also in your README, in your Bitbucket, GitHub, whatever, you can see it there. But having it available with the search engine, that's already helpful. But right now I can't put a number or a price tag on that.
Okay. If it's okay, I would have another question. I guess that you have had some kind of documentation system before using Backstage. So how do you manage, or did you use the backlinks in Backstage to connect both systems together during the transition phase, or is this maybe still in use and so on?
Yeah, the stuff we onboarded so far, most of the documentation was in Markdown files in Bitbucket. So that was, I would say, quite an easy transition. In general, I think we have still a way too large number of documentation places for things that aren't yet in Backstage. There are lots of backlinks to Wiki, so we use Confluent, so that is back and forth. Overall, the search covers some of that, but it is still, as part of the onboarding for other systems, an ongoing process.
Thank you.
But actually, for that part also, at least from my experience, the Stack Overflow integration helped almost the most, if that's English, since a lot of answers what we have in there then link to the next documentation. So it's maybe one interaction more, but at least when I think about what I'm doing, most of the time I end up looking at Stack Overflow and then I'm good.
Any more questions? Yes.
Thank you. I'd like to know how much Backstage brings by itself and how much you can use it, or how much custom software development you need to do until it makes sense, and how long it took you until the first team was working with it.
There are a bunch of integrations. Backstage.io, I think. So there is a number of plugins in the plugin catalog where you can quite easily integrate. I think the development effort is now slowly showing up with extending the plugins. Right now, I think we've been mainly good with stuff that's off the shelf. The most effort that we had to put in was actually creating those catalog info YAMLs that you put in the repo. So figuring out who is the owner, what are the dependencies. That is also what I mentioned with the automation that is manually listed in the YAML. So that is a bit of a downer to have to invest into listing what dependencies do I need first. Percentage-wise, I would say that until now it's been mostly configuration, not so much development. Of course, there is some with the plugin integration. You often end up having to add something in React to use a new plugin. But distribution, I would have to guess, to be honest. But mostly when thinking back, it was configuration.
Any more questions? No? I guess that's it. Many thanks.
Thank you.